And you're talking about the 16 book problem, right?
Yeah.
Okay. This is 4 to the 2x plus 3 equals 5 to the x minus 2. We have two exponential expressions. Their bases are not the same. And there's no way that I can make those bases the same. So what could I do? What are my available options? Take the log of both sides. While we can take a log of any base to both sides, you want to choose one that's on the calculator so that you're going to be able to evaluate it. Either one that's on the calculator would be fine. Do you guys want to do natural log or common log up here? Natural's the first one I heard. It does not matter. You get the same answer either way. Natural log is what I heard first, so I'm going to use that one. So I'm going to take a natural log of 4 to the 2x plus 3. This is number 16 from the homework that was due, from the 5-6 homework. Natural log 5 to the x minus 2. Now that we've taken a log of both sides, what can I do now with this that I couldn't do before? Power property. So we're going to drop our exponents down in front. When they come down in front, they go from being exponents to being what? They are now coefficients. 2x plus 3 is a coefficient. Make sure you put that expression inside parentheses. It is getting multiplied to the natural log of 4. Same thing over here, because that exponent that is now a coefficient is a whole expression. It needs to be inside parentheses. Natural log of 5. What would you do if instead of 2x plus 3 times the natural log of 4, it was just times 4? Distribute. That's exactly what we're going to do. The natural log of 4 is just a number. It's a number that you can put it into your calculator and it'll give you the decimal approximation. We are going to distribute this. I'm not going to grab my calculator yet because I don't want to work with anything that's not exact until the very end. So I'm going to have 2x natural log of 4 plus 3 natural log of 4 equals, what should we do over here? Distribute. X natural log of 5 minus 2 natural log of 5. What's the goal in the problem? Find x. Where is x right now? On both sides. If I'm going to find x, do I want it on two separate sides? So how do I get them to the same side? Subtract. I'm going to subtract x natural log of 5 from both sides. And at the same time, I'm going to subtract 3 natural log of 4 from both sides so that I can get my things that are just numbers to one side as well. This will cancel here. This will cancel here. Can I combine these natural logs together? Nope. So 2x natural log of 4 minus x natural log of 5 is equal to, can I combine these logs? Nope. They're not like terms. Negative 2 natural log of 5 minus 3 natural log of 4. We got our x's to the same side, but it's part of both terms. what can I do to extract it from those? Take out an x. We're going to factor out an x. When we brought those exponents down and they became coefficients, that means we're using multiplication now, and that's what allows me to factor here. So I have x times 2 natural log of 4 minus natural log of 5 is equal to, I'm just going to recopy this line up above. How can I get x alone from here? Divide. And divide both sides by 2 natural log of 4 minus natural log of 5. Do it on both sides. You cannot simplify or cancel things out. Just pop it in the calculator. The nice thing about my yellow calculators that you guys will be using for the test and the final exam, it has a fraction button on it. So rather than putting it in with division with lots and lots and lots of parentheses, the button that says n over d is a fraction key. Push that button, then you type in your numerator. Use the arrow key to type in your denominator. And you should get approximately negative 6.343. What else would you guys like to go over? Yes, sir.
Number 36 in the book.
Number 36 in the book. Absolutely. Okay, this is e to the x. Make sure I copy this down right. Plus 4e to the negative x is equal to 5. This is a quadratic type problem. One of the ways I know I'm looking at a quadratic type problem is I'm adding these bases. Because I know there's nothing that I can do to combine these together if I'm adding two of the same base. If I'm multiplying two of the same base, yes. But adding two of the same base, not so much. So now we need to figure out what we're going to let u equal so that we can do our u substitution. I'm going to rewrite this. E to the x plus 4. E to the negative x is 1 over e to the x, right? Is equal to 5. I really don't like having fractions like this. Plus, it's going to make it really hard to work with as a quadratic type if I have that fraction. How could I clear the fraction out? I could. And it's possible to do it that way.
Multiply by e to the x.
Multiply by e to the x. I think that's probably the easiest thing to do right now, and it'll make these other pieces much more obvious for us. So I'm going to multiply everything by e to the x. Do it to one side, got to do it to the other side. E to the x times e to the x would be what? e to the x squared,
Or 2x.
e to the 2x, because remember, we add those powers together. So x plus x. Plus, what's going to happen here?
4x to the e.
It's gonna be 4.
It's just going to be 4, because it's going to cancel with my denominator there, right? Okay, let me write down just a little bit clearer what I'm doing here. E to the x times e to the x plus 4 e to the x times 1 over e to the x. This is where this is canceling. That's why it's just a 4. Here we add these two powers together. So I have e to the 2x plus 4 equals what? 5 e to the x. I told you at the beginning we were working with a quadratic type, and I told you what I saw that gave me that kind of hint that I was looking that way. Quadratics need to be set equal to what? 0. So let's subtract 5 e to the x from both sides. So e to the 2x minus 5e to the x plus 4 equals 0. What should I let u equal? E to the x. Let u equal e to the x. So now it would be u squared minus 5u plus 4 equals 0. How would that factor?
-1 and -4.
-1 and -4. U minus 1, u minus 4 equals 0. So what does u equal? 1 and 4. Are we finished?
No.
No. We have to substitute in now e to the x in the place of u. E to what power would be 1? 0. X equals 0. How would I solve for x in the next one? Natural log. X equals the natural log of 4. And there's my two solutions. You can check those. If we substitute it back in, what happens if I put 0 in the place of those x's? E to the 0 plus 4 e to the -0. What would I get? 1 plus 4, which is 5. So it works there, right? If I take the natural log of 4 and substitute it in, ln 4 negative ln 4, what's going to happen right here? 4 plus, I could rewrite this as 4 over e to the ln 4, right? What would the denominator be? 4 plus 4 over 4, which comes out to be what?
5.
Yeah, 4 plus 1, which is 5, yes. What else would you guys like to look at? Anything from the book? Anything from the review? Yes, ma'am. 6A on the review. Is 6A a quadratic type? No. How did I know by looking at it that it was not going to come out to be a quadratic type? Yep, we've got this multiplying right here. When I see a plus or a minus between two of the same base, that's when I'm looking for my u substitution. I'm going to keep the left side e to the x squared. How can I rewrite e to the x to the fifth? E to the 5x. How can I rewrite 1 over e to the fourth? E to the negative 4. Same base, being multiplied together, what do I do with those powers? Add them. So e to the x squared equals e to the 5x minus 4. What can I do from here? Yeah. E's I can just ignore from here on out because they're identical. It's not a quadratic type problem. It's just a straight up quadratic problem. Where to from here? Yep, subtract 5x, add 4. So x squared minus 5x plus 4 equals 0. This will factor to be what? Minus 1 and minus 4. So x is 1 or 4. Are those both valid? Yes. Did I even need to think about whether they were valid or extraneous?
No.
Why not?
Because
They're positive, yes. There's no logarithms. We're working with exponential expressions here. What's the domain for exponentials? What things are you allowed to use for x in an exponential expression? Anything you want. It's all real numbers. The only time we have to look for extraneous things is when the domain is not all real numbers. Any others in part 6 that you guys want to look at or talk about? F? Sure. Where should I start on F? Divide by that coefficient out in front. So I'm going to divide both sides by 5. 8 divided by 5, I could express that as a decimal, but I'm going to leave it as 8 over 5. What can I do from here? Put it in log form. What's the base of my log? 2. Log base 2 of what? 8/5 is equal to 3x. I want x by itself. Divide both sides by 3. There's only one problem that I'm running into when I go to put this in my calculator now. These calculators, the yellow calculators that you're going to be allowed to use tomorrow, don't have base 2. Change a base. So, what will my numerator look like now then? Common log of 2. Like this? That one goes on the bottom. Why does that one go on the bottom? Yeah. Argument in the numerator, base in the bottom. So in my numerator, I have common log of what? 8/5. So common log of 8/5 divided by common log of 2. Whole thing divided by 3. And you get about what? Point what? Yes. When you round this, you get about 0.2 0.226 or 0.23. Yep. What else do you guys want to look at? Part B? D, got it, yes. I only have logs on one side of this equation. What can I do with those logs? Quotient, yep. We're gonna condense this using our quotient property. So I'm gonna have log base 4 of x squared minus 9 over x plus 3 equals 3. X minus 3. So I had this question earlier today. Can you? Yes. Will you get the right answer? On this one, yes. If you cancel out things with x's, you can end up eliminating a possible valid solution. On this one, when you do it, you're actually eliminating something that will end up being an extraneous solution. But I would caution you against canceling it out at this point in the event that it actually ends up being a valid solution and then you've only found one of them instead of both of them. What can I do with it now that it is just a single log? Change it into exponential form. So 4 to the third equals x squared minus 9 over x plus 3. I'm going to multiply both sides by my denominator. So that is 4 to the third is 64. So I'm going to have 64x plus, I think this is 192. Okay. Say somebody correct me if I'm wrong. Equals x squared minus 9. We're quadratic. So I'm going to set it equal to 0. 0 equals x squared minus 64x minus 201. So now I need to factor this thing. 201 looks intimidating. What can go into 201? 3 can go into 201. Negative 201, negative 64. It's 3 and what? Negative 67. There's the two numbers we needed right there. So 0 equals x plus 3, x minus 67. So my two solutions here are negative 3 and a positive 67. Like I said earlier, this one is extraneous. This one is valid. Why is negative 3 extraneous? Has to be greater than 0. It comes out to be exactly 0, and it has to be strictly greater than 0. What else would you guys like to look at? Yes, ma'am. 4A. And which one? 8A. 4A, 8A. Sounds good. 4A. Evaluate the following. Log base 2 of 8. 2 to what power gives you 8? 3. So this whole thing would simplify to be 3. So 3 plus, close, 2, because it's 5 squared, right? Plus what? 7. So this is 12, right? B, absolutely. This would be log base 2 of 2 cubed. That's why it's simplifying to be 3. And then log base 5 of 5 squared. So it's following the exact same pattern as with the last one. Part B. 2 to what power is 1 over 16? Negative 4. So this is negative 4 here. This middle term. First thing I would do here is bring this over as a power. I would also rewrite the 16 as what? 4 squared. So I'm going to have log base 4 of 4 squared, but then to the power of 4. What happens right here? You multiply those together, and then my bases will cancel. So this is going to simplify to be 8. What about this last guy over here? One third. Because this would be natural log of e to the 1/3 power. So I've got negative 12 plus 1/3. So negative 11 2/3.
How is it 1/3?
Because when you have a root, that's a fractional power. The cubed root of something is the same thing as that thing to the 1/3 power.
Could it also be change of base with the middle term?
Change of base.
Log of 16 over log of 4, and then you get 2.
Yeah.
Negative 4.
Yeah, absolutely you could. Instead of using the powers property, you could have also just said this is 4 times log base 4 of 4 squared, which would simplify, and you'd have 4 times 2. You get 8 that way. Absolutely. Number 8, part A.
Ms. Wolf,
Uh-huh.
will the base and the argument always cancel out when they're the same?
Yes. Yes, when the base and the argument are the same, they will cancel out. Yes.
What about when
5B. Let me do 8A first, and then I'll come back and do 5B. Oh, this one. I don't like the way the computer printed this, because it's really hard to tell that that 3 is a cubed root, not an exponent on the x. I would use my quotient property first. So ln of 3x cubed root of w. See, even I messed it up. Minus natural log of v plus 17 to the 5th power. I would use the product property next. That's going to happen over here. I cannot touch anything in this second argument, that v plus 17. There's no way I have a breaking apart addition in an argument. It just has to stay like that. So I would have the natural log of 3 plus the natural log of x plus the natural log of, I'm going to go ahead and write this as a fractional power, w to the 1/3 instead of the cubed root, minus the natural log of v plus 17 to the 5th. And then I would make use of my powers property. I would drop these exponents down into the front as coefficients. So fully expanded, I would have natural log of 3 plus natural log of x plus 1/3 natural log of w minus 5 natural log of v plus 17. And again, that v plus 17, I can't do anything with that. I can only break apart multiplication or division or powers? And you said 5B? Okay. Part B. This is another one. This is kind of why I showed what I did back here on number 4, part B. We could use the change of base there, multiply by the 4. Here, I would use my powers property. I would bring this 6 over as an exponent. 7 to the power of log base 7 of 2 to the 6th. What did you say? When my exponential base and my logarithmic base match, they cancel each other out. So I'm going to have 2 to the 6th power, which would be 64.
So why wasn't 4B 16?
Why wasn't 4B 16?
Oh, wait.
You know, in this one, we have a log with our base and the argument. When the base of the log and the argument match, they cancel. When the base of the exponential and the base of the log match, those also cancel out. Anything else you guys would like to look at? 2B? Or not 2B? Haha. I know, I'm so amusing. Whenever we're talking about inverses, what does that mean? Switch X and Y. But they're asking me about domain and range. Yes. If your X's and Y's are switching, that's going to swap your domain and your range. So I need to figure out what the domain and range is on h of x, and then I'll just swap them for my inverse. What is the domain? What are the things I'm allowed to use for x in this exponential function? All real numbers. So in my inverse, that would be my range. What's the range of this exponential function? Positive numbers. So how do I write that? 0 to infinity. So that would be the domain of my inverse. 0 to infinity. Yes. I love the reasoning that I'm hearing going on over here. The reason that the range is only positive numbers is it does not matter what we put in for x. I'm never going to be able to get 0 as an output. I'm never going to be able to get a negative number as an output.
If it was like negative 3 x plus 2, like negative 3 to the power of x plus 2, what would that be?
So you said negative 3 to the power of x plus 2?
Yeah.
The range for this then would be negative infinity to 0. There's nothing I could put in there and ever get a positive number back. Because this is technically the same as negative 1 times 3 to the x plus 2.
So like, if I was to put, so if I put x into 0, right, and I got negative 3 to the power of 2, I wouldn't do like negative, I would do like 3 to the power of 2 then times negative 1.
Yes. Order of operations would be exponents first, and then the negative on the front. Whenever you see a negative in front of a number, it is technically always a negative 1 times that thing.
Unless it's like parentheses around it.
Unless it has parentheses around it, absolutely. Even then, technically, it's -1 times that thing, but you would do that first before taking it to the power. Wonderful clarifying questions, guys. I have time for 1 or 2 more, depending on how long they are. If there's anything else that you guys want to see or talk about. 2A? Yeah. Without actually finding the inverse. So again, I want to find the domain and the range of this. Domain is all the things I'm allowed to use for x. Is there anything that I'm not allowed to use for x? -3. So what would the domain be here?
-3 to infinity.
That's part of it, but that's not all of it. -infinity to -3, union -3 to infinity. Because in this one, it's not that it has to be a positive. It can be positive or negative. It just can't be -3. And then my range on this, is there anything that y will never equal 1? This one has a horizontal asymptote. At y equals, we divide those leading coefficients. So y will not equal 1. So our range would be -infinity to 1, union 1 to infinity. And so we just switch that for our inverse.
So to find what the y can't you just divide the coefficients?
If the degree is the same top and bottom, yes.
What if it's not the same?
If it's not the same, if it's bottom heavy, then horizontal asymptote at 0. If the degree is higher on top, then it's got a slant asymptote. Do you remember the oblique asymptotes that we talked about in rationals? Yeah. Quick question. My question to you now. On number 10, how in the world would I set up number 10? Did they even give me enough information for this? Yes, I do have enough information. For number 10?
Oh, that would be 3.
3 equals. 3 equals what? E to the RT. So it'd be E to the 0.06 T. We're using our A PERT, but we don't need the starting amount because we know that we want it to triple, so whatever the starting amount is, the ending amount is going to be 3 times as big. First thing I'm going to need to do is divide. When I divide, I'm going to get a 3. You do not need the initial amount if they say things like doubles, triples, quadruples. Do you guys have any other last-minute questions for me? Yes, all of the answers will be up on Canvas after school today with all of my work, absolutely. I was told earlier today that this module is locked. I'll make sure that that gets unlocked as well. That was just a mistake on my part, but there's nothing interesting up yet. So.